This video is part 3 of Chapter 8 Complex Designs for PSY 222 Research Methods in the Psychological Sciences. In the previous video, we had talked about how to detect and interpret interaction effects. Sometimes interaction effects are that you see perhaps in a line graph are actually not true interaction effects, but maybe the result of what are called ceiling or floor effects. And what's happening with these effects is when you can have a statistically significant apparent interaction effect, but it's mistaken. The means for one condition, for example, might max out at the highest possible score on a scale for participants. That's called a ceiling effect. Or you can have the opposite thing happen where the means for one condition, say if a task is super difficult, you may have people on average at the lowest possible score, and that's called a floor effect. With a ceiling effect, it could be that maybe you have a task that's super easy, or a different kind of thing where, since your participants are all pretty young, maybe you're a health psychologist and you're studying some health indicator like blood pressure or cardiac function. Well, they're all young. Chances are pretty good they're going to have super high, super healthy values. That would be a ceiling effect. So that would, artificially perhaps produce an interaction effect that can't be interpreted as a true interaction. So essentially, if you have ceiling or floor effects, what happens is that any interaction that you see, if it's significant statistically, is not, you can't interpret it because it's likely due to a measurement problem as opposed to an actual interaction between your independent variables. Now this graphic shows you an example of what you would see if you were doing a line graph of what looks like a ceiling effect. So if the participants hit the ceiling on this easy task, what it appears that they've leveled out, when in fact, if the task was a different kind of task, you wouldn't see that leveling out. That leveling out creates the artificial appearance of non-parallel lines. If you could go beyond that ceiling, like greater than 100%, then you would see continued parallelism. But the measure itself doesn't go any higher than 100%. So what you see here, the effect of the amount of practice time, eventually ceilings out for the easy task in comparison to the hard task. And that makes the appearance of an interaction when there isn't one. So increasing practice time in this particular example improves test performance on the hard exercises, but performance levels off with the easy tasks. So you really can't say anything about, you can't say, for example, that practice time only matters for hard tasks. That would be an inappropriate interpretation. It is perhaps that the tasks you selected in the easy task condition are too easy, or the way they're written creates aha type learning where you have an effect of differential transfer. So regardless of what the cause of the ceiling effect is, you have an uninterpretable and likely significant interaction. So unfortunately, that means that this kind of comparison would be uninterpretable. There is the possibility of testing for interaction effects in what are called natural groups designs. And that, remember what a natural group is. It means that the participants bring with them a variable that creates different groups that can be compared. So you may have people broken down by their sex, broken into groups based on an experience they've already had. Now, your authors use this word. I want you to be careful when you're thinking about natural groups variables are described as correlational in your text, that they're not using the word correlational in the sense of the statistic correlation coefficient. They're using it to suggest that given that you are not randomly assigning people to these naturally occurring groups, you cannot infer cause and effect based on that variable. Now, as a practical matter, we tend to talk about these kinds of differences in terms of at least the theoretical possibility of cause and effect. But this is when your authors use this phrase, these variables are correlational, that's what they mean. They mean that you need to put the brakes on before you make a causal conclusion about differences between these groups. Still, though, you can use this design to test a theory about the potential differences between these groups. So just off the top of my head, let's say you have a theory that sex, male versus female, for example, is the cause of differences in test scores on spatial skills tests, for example. And you would test using a complex design, maybe a couple of different types of tests or differences in levels of difficulty. And then you could make that argument that the pattern of data that you see supports your theory about sex differences. Now, there are some steps that you need to take. Apologies, my grand dog wants into my recording studio. So there are some steps that you need to take when you're trying to make causal inferences about differences between naturally occurring groups of participants in these types of designs. So you have to state your theory. You start with that. Why would you, for example, believe that male participants would have an advantage in spatial skills tasks? Why would female participants be at a disadvantage in terms of their performance? Is there some neurobiological explanation of a potential theoretical process that would underlie those differences? And historically speaking, if I'm playing with this example, there have been theories about that. They're tricky theories. They're theories that don't always stand up to the test of the data, the actual data. Then you have to identify an additional independent variable that you can manipulate. And this is going to be a variable that you think will help elucidate the theory. So, for example, you could select different types of spatial skills tests, such as a mental rotation task versus a map memory task, which both rely on spatial skills, but they do so in a different way. And you're going to make that sex-based comparison between males and females, looking at both those different tests of spatial skills. Then you're going to look for an interaction effect, and you want to know, do these sex differences hold up when we're comparing different kinds of spatial skills tests? If the natural group's variable, you're going to look for a main effect, but you're also going to look for an interaction effect with the manipulated variable. In this case, if you've got a significant interaction effect and it's in the direction that you predicted, you need to look then at your main effects and come up with an explanation for why the groups differ in the particular way that they do. Now, you can look at some other examples, and your authors mentioned this study of the Barbie doll, the Barbie doll study in a previous chapter. I pulled the reference for it because I was curious about some questions I had about the measures that they were using. So I pulled the reference, and here it is. And essentially, they were looking at school children, so 5 to 8-year-old girls. I believe that the data was collected in the United Kingdom. And I pulled this out of the article. It may be a little hard to see on the video, but essentially you have the exposure condition, and these were storybooks that these children looked at. You had images of a classic Barbie who has, absolutely impossible physical features versus images of an Emmy doll, which on the previous slide I had images of the two. The Emmy doll is what was roughly at the time period when those dolls were produced, about a size 16 or 18, which is, it was seen when the doll was created as the average size of the female figure. So you have images of the Emmy doll in the storybook, and then you had control images. And I pulled this image so that you would be able to see what they mean by images. So you have a picture in the storybook of Barbie getting dressed. Barbie in a top and jeans, Barbie in a skirt and top, Barbie in trousers, top and shoes, Barbie in the supermarket, Barbie in a long pink dress. Then you have Emmy in pajamas, Emmy in a top and jeans, skirt and top, trousers, top and shoes, Emmy in a different dress, Emmy in a long pink dress, and so on. The control images did not include pictures of women. So they were reading storybooks, and again, these are very young children. Then they wanted to test for differences across these conditions in terms of a variety of dependent variables. One of those dependent variables was mean body esteem score, so how much the girls liked their bodies. They also had grade level, was the natural groups variable. So you aren't randomly assigning people to their grade level. They are the grade level they are. So there are sources of error there, depending on who these children are and how they landed, just in these naturally occurring groups. So that's the natural groups variable. Then you have your randomly assigned variable, independent variable. So in the kindergarten group, you had an equal number roughly of participants in the Barbie book, the Emmy group, and the neutral group. Same for the first graders. A random number who saw the Barbie book, the Emmy book, and the neutral book. Now this column over here, that is collapsing across all versions of the picture book. And you can see the means there. For the kindergartners, you have slightly higher, the appearance, just eyeballing it, slightly higher body esteem than the other two groups. Down here, you have collapsing across age groups. So you're combining kindergarten, first and second, and what you see is that those who saw the Emmy book, regardless of their age, tended to report higher body esteem than apparently the other two groups. Now, obviously, you're talking about fairly small difference. That's why I want you to eyeball these means. 14.9, you could round that up to 15, right? 14.90, 14.93, 15.19. And you have to ask yourself the question, is that a meaningful difference? Well, that's why we do inferential tests. Now down here you've got 14.45, which could be rounded to 14.5, 14.96, which could be rounded up to 15, 15.6, which you could theoretically round up to 16. So again, we're eyeballing the means and seeing whether we think we see a pattern here. When we look inside to try and make some guesses about potential interaction, you can see why the line graphs are helpful, because you've got all these numbers and it's hard to look and just see, are they going to be non-parallel lines? So if we plot them out, and I did this in PowerPoint where I plugged the numbers into the graph making element that's built into PowerPoint. And for the kindergartners, and obviously what you see is non-parallel lines, right? For the kindergartners, you have the Barbie producing the lowest body esteem, the neutral category in the middle, and the Emmy doll the highest. Same for the first graders, same pattern for the first graders. And then you get this weird reversal in the second graders. So we're still talking about very young girls. But for the Barbie, and this is, one of the interesting things that you're looking at when trying to interpret these results, you have the widest difference with the youngest kids, where you're getting the biggest boost from looking at the Emmy doll, but you see a collapsing of those findings and even a slight reversal with the older kids. And now the authors, they interpreted some of this in terms of the older girls the more subject they are to peer pressure and the demands of image. So further testing and exploration obviously would be required. Now, what Dittmar et al., they argued that there was overall, remember back to that graph where I plugged in the means for you, that the children exposed to the ME images, when you look at the main effect, the overall effect of the picture book, they did tend to report significantly higher average body esteem than those exposed to the Barbie and the neutral images. There was also an overall effect for grade. Body esteem was highest in the youngest group, and you had an interaction effect with those youngest groups. The interaction between the two IVs, the effect for the version of the book holds for the two youngest groups, but not for the older group. In fact, you see a reversal. And part of their interpretation there was about just the older girls get, the more intense the pressure is to internalize the image of thinness that's coming from culture. And that concludes our coverage of complex designs in Chapter 8.